Hi everybody. In this video, we are going to discuss about union. So, what is actually a union? Union is very similar to a structure. The only difference is between a structure and a union is union members get stored in the same location. That's the only difference between structure and union. So creating everything is going to be the same. Accessing the members of union, all these things, a pointer can be there, pointed to a union, everything very similar to a structure. But the only difference is when I create a structure, for every structure member, a memory space, a separate memory space is allocated. Whereas here, the same memory space will be used by all the members of a union. Say, for example, I'm creating a union. So when I create a union, I will have to use the keyword union. And as usual, the tag for the union. Let me have a variable called int grade. Okay, or I can say int average. Okay, then let me have another variable called character grade. Yeah, this is my union. Okay, now let me create the union variable, union u tag. Say my union variable is going to be u. Fine. Okay. Now, what do you assume the memory space of u will be? The size of u will be? If this is going to be a structure. Say, for example, if I create a structure like this and I create a structure variable u, so the size of u structure variable will be, assume it is 4. The size is 4 for integer variable. Okay. And the size of character is going to be 1. So my structure variable will occupy the size of 5 in the case of a structure. Now, if this is going to be the union, okay, I'm creating a union variable. So in that case, we know that the same memory space will be used by all the members of the union. So what it will do is, it will take the memory space of a biggest data type which is available in the member. Say for example, int occupies 4 bytes, character occupies 1 byte. So the size of this union will be 4 bytes. Okay, that's the biggest size. Okay, so that will be taken as the size of union. So AVG will be stored in the same 4 byte. This grade also will be stored in the same place. That means at a time, only one member can be assigned or initialized, or one member can use the memory space. Right? Now, why do we need this actually, this type of union? Say, for example, the same example let us take. Here, I'm assuming that in a college, you can either opt for mark or you can opt for grade. Okay, there may be some subjects where you either opt for mark, you wanted the final marks listed in your mark sheet, or you wanted the grade A, B, C like that listed in your mark sheet. So you wanted, you have the option of choosing any one of this, not both. Okay, you can either choose mark in your final mark sheet or grade in your final mark sheet. So in that case, if I'm going to create a structure for that, I'm going to waste, because at one point of time, I'll be able to use either a integer or a character. So I need not have memory space to store both these members. So in these cases, union is really useful. Say for example, in our real life, let us take a switch box, or no, let us take some connection. So at a time, I wanted either a network connection, no, either a Wi-Fi connection, or I wanted a TV connection or a Fire Stick connection. I don't want everything at the same time. So what I do, I can just have one connection. I can just replace it whatever I require. If I'm going to have 3 connections, I'm going to waste. In that case, I can just have one connection I can use that connection for whatever purpose I wanted to. This is what the union does. Okay. Or if I have very less memory space available, I need not waste the memory space, I can go for union. Okay. So here in this example, if the college has the option of choosing either the average, either the mark as in my mark sheet or the grade in the mark sheet, not the both. Okay. So in that case, I can go for union. Fine. Now let us try to print the marks. I'm sorry, print the size of the union. Okay. So let me try to print the size of union. So when I run this program, you can see the size is going to be 4. Okay. I've not included stdio.h. That's the error here. Let me include stdio.h. Now when I run this, you can see it is 4. That is the size of union u variable is 4. That is, it has taken integer size because that's the bigger size. No, when you compare integer with the character, integer size is bigger. So it takes us 4 as the size of the union. Fine. Okay. Now let us try this. Then when I wanted to initialize the value for a union, I will be able to initialize value only for the first member. I cannot initialize value for all the other members of the union because the same memory space is going to be used by all the members. So at the same time, all the members cannot have some value. Where do I store it? Okay, so when I want to initialize a value, I can only initialize a value for the first member of my union. So here in this case, for AVG alone, I can initialize value. Okay, now let me try to print it. Say, for example, let me have it as 95. 97. Okay, now let me try to print these values. So percentage D. Okay, I wanted to print average equal to percentage D. Okay, size equal to, then average equal to percentage D. Then I wanted to print grade equal to percentage C. Okay, that is I want to print U dot because I can access the members of a union using dot operator. Okay, U dot AVG comma U dot grade. Fine. So what happens? I've initialized use average to 97. Okay, so in that case, that's the same, that's the only memory space available. I've stored 97 in that. So when I try to print average, it prints 97, no doubt. Then again, when I try to access this grade, it accesses this grade in the same location. So 97 is there in the same location. So that will be the grade. Is that clear? Let me run it and show it to you. You can see here, size is 4, as we know. Average is 97, that is what I initialized, right? Then you can see grade equal to A. The ASCII value of A, small a is 97. So grade will be A. Are you following it? Because I've initialized average to 97. It is stored in that 4 byte of memory space. Now when I print U dot average, it prints that 97. Now when I try to access the second member, where do I access it? In the same memory space. So whatever value is there in that memory space will be accessed. Fine? Okay. Now let me try to do something else. Say for example, U dot grade. I'm going to assign value to a grade. I'm going to assign B to grade. Okay. Now let me print. So you can see here, I've assigned B to grade. So this is fine, grade equal to B. The same memory space is being accessed by this AVG. So you can see AVG equal to 98. The ASCII value of B is 98. So it prints 98. Okay, so that's the idea of a union. Union is it takes the biggest members type, biggest type. Okay, if it has n members, it will first find out the biggest data type member and takes that size as the size of the union variable. And at a time only I can store one value. All the members value will be stored in the same location. And I store the first member value. Okay. Now when I store the second member, the first member's value will be replaced by the second member's. because it's going to be stored in the same memory space. This will be really useful, no, when you have, say, one example, what I said is, when I wanted to either print the average or the grade, not both. If you have that option to choose, in that case, union will be helpful. Okay. If you have very less memory space, union will be helpful if I'm going to share the memory space. Okay. Hope you understand this. Have a great day.